Hey everyone, and welcome. Today, we're diving into the story behind a national celebration of science and the absolutely incredible mind it honors. We're talking about India's National Science Day. And it's a story all about pure curiosity, undeniable genius, and a discovery that literally changed how we see light itself. So, let's get right into it. The date, February 28th, is no accident. It isn't a birthday or just some random holiday. It pinpoints the exact day that a groundbreaking discovery was announced to the entire world. So what was this big discovery, and who was the genius behind it all? To really understand why this day is so important, we actually need to look at two key moments in time. First up, we're landing in 1928. This is the year it all happened, the year of the discovery itself. It was a moment when one physicist, working in a pretty modest lab, found a fundamental, brand new piece of the cosmic puzzle. Okay, now let's jump forward in time almost 60 years later to 1987. This is when India's government decided that the anniversary of that incredible 1928 discovery should be celebrated every single year. And the goal? Well, it was to spread a message of science and to get people all across the nation thinking scientifically. And here he is, the man at the very center of our story, Sir Chandrasekhara Venkata Raman. And get this, he wasn't just any scientist. He was the first person from India, and in fact the first person from all Asia, to win a Nobel Prize in any branch of science. A huge, huge deal. So who exactly was C.V. Raman? Well, to call him a genius is, frankly, an understatement. His story reads less like a typical biography and more like the origin story of a science superhero. I mean, just look at this timeline for a second. Getting a bachelor's degree at 16 is amazing enough, but publishing original research while you're still a student and then finishing your master's degree by the time you're 19, that's almost unheard of. This just shows us we're not talking about some bright student. We're talking about a mind that was already contributing to physics while most people were still learning the basics. And here's where the story takes a twist. You would think a mind like this would go straight into a top-tier research lab, right? Wrong. He actually started his career in the civil service as an accountant, but his passion for science was just unstoppable. He would conduct all his research on sound and light in his spare time at a place called the Indian Association for the Cultivation of Science. It's just an amazing testament to his dedication. Now, Raman's first major puzzle didn't come from a textbook or some lab challenge. Nope. It came from a moment of simple, profound curiosity during a sea voyage back to India in 1921. He was staring out at the deep, brilliant blue of the Mediterranean Sea, and he asked a question that seems almost childlike but is actually super complex. Why is the sea blue? And he just wasn't satisfied with the answer everyone else accepted. You see, at the time, the accepted explanation came from the famous physicist Lord Rayleigh, who basically argued the sea just reflects the blue sky. Simple enough. But Raman had a hunch it was more than that. He suspected the water molecules themselves were actually playing a role scattering the light and creating that deep blue color from within. So what did he do? He used a simple pocket-sized tool, a prism, to block the glare and reflection from the sky. And what he saw was revolutionary. Even without the sky's reflection, the sea was glowing with its own brilliant blue color. In that one moment, with a simple observation, he disproved a long-held scientific belief. The water wasn't just a mirror, it was making its own color. This question about the sea totally ignited Raman's fascination with how light scatters. And that fascination would lead him from the color of the ocean to a discovery that helped prove the fundamental and, let's be honest, kind of strange nature of light itself. So a key piece of inspiration for him came from another Nobel-winning discovery called the Compton effect. Now, what that basically showed was that X-rays, which everyone thought of as smooth waves, could sometimes act like tiny little bullets or particles. This idea that something could be both a wave and a particle at the same time was totally revolutionary, and it really got Raman thinking. And this quote right here, it perfectly illustrates his mindset. When he heard about Compton's prize, he didn't just see a fascinating discovery, he saw a challenge. He told his colleague that if this weird quantum behavior was true for X-rays, it had to be true for visible light as well. And he didn't just want to prove it, he was aiming for the Nobel. So, on February 28, 1928, the moment arrived. The experiment was beautiful in its simplicity. They shone a beam of single-colored light into a liquid. As they observed the scattered light, they saw something astounding. A tiny, tiny fraction of that light, we're talking like 1 in a million photons, came out as a different color. Now, a different color means a different wavelength, and a different wavelength means the light's energy had physically changed. It had either lost or gained a little bit of energy after bouncing off the molecules. This was the proof he was looking for, and that phenomenon was named the Raman Effect. It was a groundbreaking piece of evidence for quantum theory. It showed that light wasn't just some continuous wave, but was made of distinct little packets of energy, photons, that could have a physical interaction with molecules, literally exchanging energy with them. And remember his ambition? Here is the ultimate proof of his confidence. In 1930, he was so certain he would win the Nobel Prize for this discovery that he booked his travel tickets to Stockholm in July. The winners weren't even announced until November. And of course, his confidence was totally justified. He won. But the story doesn't end with the Nobel Prize. In fact, you could say that was just the beginning. The Raman Effect wasn't just some scientific curiosity. It was a tool that unlocked entirely new possibilities for science. So here's the crucial part. The exact amount of energy that the light gains or loses, that specific change in color, is a unique fingerprint for the molecule it interacted with. A water molecule will shift the color differently than a sugar molecule. This realization led to the creation of Raman Spectroscopy, a powerful technique used today to identify substances at a molecular level. It's used in airport security to screen for dangerous materials, in medicine to detect diseases, and in forensics to analyze evidence. His incredibly fundamental discovery has practical applications all around us. Which brings us right back where we started, to National Science Day. It's a day to remember Raman's achievement, but it's also about carrying his spirit of curiosity forward. Each year has a different theme, focusing on everything from the role of women in science to creating wealth from waste, making sure that the day stays relevant and inspiring for brand new generations. When Raman passed away in 1970, Prime Minister Indira Gandhi gave this beautiful tribute, and it's just so perfect. Like a diamond, his mind could take in the light of the world, analyze its many facets, and reflect it back with brilliant clarity for everyone to see. And that leaves us with one final thought. C.V. Raman's entire journey began with a simple question about the color of the sea. It's such a powerful reminder that groundbreaking discoveries don't always start in a high-tech lab. They start with curiosity. So what are you curious about?